Hello, everyone, and welcome to today's webinar about ecoinvent version 3.11. We have published this new version just 2 weeks ago, and I will have the pleasure of giving you some highlights about what it contains. I'm David Fitzgerald, the database operations lead at ecoinvent, and I will be explaining today what are the main updates that we have made for version 3.11. Given the large number of updates contained in this new version, I will only be able to give the highlights of the biggest changes, but I will also mention where you can find more details about the different updates we have made. So to start with the overview of what will be presented today, for those unfamiliar with ecoinvent, I'll first give a quick introduction about who we are and what the database contains. I'll then explain what has been updated for version 3.11. I will highlight the main updates that were done for each sectors that were changed for this version. And at the end, I will also mention a few other updates that we've done that concern the whole database. So let's start with a short introduction about the ecoinvent Association and the database. So who is ecoinvent? We are a not-for-profit association based in Switzerland, which was founded 20 years ago by several Swiss research institutions. Today, ecoinvent comprises of over 80 employees, all contributing to our main activity, which is the publication and maintenance of the ecoinvent database. It's a database which contains background data on environmental impacts of products and services. Our mission is to promote and support the availability of high-quality data. We achieve this by compiling and reviewing the best available data and publishing it in the most transparent way possible. The data published in the ecoinvent database can be used for supporting all kinds of environmental studies. Some of the main ones cover life cycle assessment studies as well as greenhouse gas reporting. So what is the ecoinvent database? Our database contains data that model the average inputs and outputs of human activities, covering a wide range of products and services. Each dataset models one step of a supply chain. So this enables users of the database to track environmental impacts at each step of the supply chain of a product or service. Where does the data come from? We work with a variety of data providers from various organizations, such as research institutions and industry associations. And this data is complemented with data published in literature and from other sources. Before we publish the data, we make it go through a review process to ensure that it complies with ecoinvent's data quality requirements. Today, there are tens of thousands of users that use the ecoinvent database throughout 80 countries. They either access the data directly through our website or they use it through softwares or other tools. Finally, it's worth pointing out that the database is compliant with the ISO 14 series. Here's an overview of the main sectors for which data is available in the ecoinvent database. As of version 3.11, the database contains data for over 25,000 unit processes that model different steps of the supply chains of products and services in the sectors depicted here. And with every update, we strive to increase the coverage as much as we can for each of these sectors and for as many regions as possible. At ecoinvent, we also engage in different initiatives that cover topics such as format interoperability, data creation and management, as well as capacity building. Here on the slide, you can see a few of these initiatives. We have, for example, the Global LCA Access Network, of which we are a member of. We have also been in the past coordinators of the National LCA Database Roadmap project with UNEP. And we have also been data providers of the Environmental Footprint Data Initiative of the European Commission. Now comes the main topic of today's webinar. I will be explaining what are the main updates for version 3.11. So first, here's a list of the sectors for which we have published new and updated data for this new version. So you can see here the sectors on the left-hand side. In addition to those updates, we have also made some improvements related to life cycle impact assessment methods, which I'll be describing at the end. To give you an overview of the sectors, here's a chart showing the number of data sets for the different sectors we cover in the ecoinvent database. As you can see, the energy sector, as well as the waste treatment and recycling sector, are the ones with the most data, in large part because these are sectors where we have quite a bit of regionalized data, which is something we are also trying to increase in the other sectors. For this new version, new data sets and updated data has been added to all the sectors shown on this graph. So let's start with the fuel sector. We have three main updates that were made for this sector. The first one concerns the oil and gas supply chains. We updated the oil and gas supply chains to reflect the situation in 2023. So this is important because it means that the data in version 3.11 now reflects the changes due to the full-scale invasion of Ukraine. With this update, the high-pressure natural gas data in version 3.11 covers 57 countries and accounts for 88% of global consumption. Our coverage of liquefied natural gas, LNG, has also been updated, including 14 producing countries, which are responsible for 93% of global LNG trade. Additionally, we've revised transport data for onshore and offshore pipelines, as well as LNG shipping distances to increase the accuracy of the modeling for each region. Finally, the last update for this part concerns the data for petroleum oil. We have updated petroleum oil markets in several key regions, such as Brazil, India, Europe, and North America, to mention a few of them. And so in summary, with this update of the oil and gas sector, we have used the latest statistical data that was available at the time of the update for the oil and gas sector. So this means that the version 3.11 of the ecoinvent database contains an up-to-date picture of the supply chains for oil and natural gas for the countries that are covered in this new version. The second update I would like to mention for the fuel sector concerns natural gas liquids. Natural gas liquids represent an important commodity and feedstock for steam crackers and the chemical industry in general. And what we did for version 3.11 is make some revisions to the production process. And basically these include, for example, an update of the heat supply so that it is sourced from natural gas that is readily available on site. And we have also revised the infrastructure based on data extracted from 3 natural gas liquids plants. So with this update, we have made improvements to the supply chain of light hydrocarbons, such as ethane, butane, and propane, which come out of this process, and which are used primarily in steam cracking operations. The last major update for the fuels sector concerns the coal sector. As you know, global coal demand remains significant, driven by emerging economies like China and India. While the global energy transition is ongoing, coal still plays a critical role in the energy mix. So with this in mind, we've made several important updates to improve the accuracy and regionalization of coal supply chains in the database for version 3.11. First, we updated lignite and hard coal supply chains to reflect production volumes and methane emissions data for 2022, which was the latest data available. Among this update, we have methane emission factors that were revised using the latest data from the IEA and Climate Trace. Second, hard coal mining activities were regionalized within Europe with 4 new geographies added. At the same time, coal market activities were expanded to include 22 new geographies in Europe, as well as new markets for Japan and South Korea. Third, we enhanced the representation of global trade with 34 new import activities for hard coal, ensuring a more accurate depiction of international trade flows for coal. So these updates provide a more granular and up-to-date picture of coal supply chains globally. In particular, the high resolution of data for Europe enables more precise impact assessments for this product. And it's worth mentioning that one of the effects of this update is that the global warming potential scores have changed noticeably in China, Latin America, and South Africa. Moving on to the next sector, for the electricity sector, as we usually do with every update of the database, we have updated the electricity market mixes based on more recent statistics. For version 3.11, the data represents either the situation in 2021 or 2022, depending on the country. A notable change concerns the main source of statistical data that we have used. We switched from the International Energy Agency database to the Enadata database. This change was done in part for data licensing reasons, but also because Enadata provides a slightly more centralized source of various data related to the energy sector. Regarding country-specific updates, similar to the last version, we have updated the market mixes for China, India, Brazil, and Switzerland based on national statistics, which for version 3.11 represent the year 2022. For US and Canada, we have for version 3.11 also switched to using directly the national statistics, while before we were using the data from IEA. The data for these two countries is also for 2022. For all other countries, the electricity mixes are based on data for 2021. The other update we have made for this sector concerns the residual mixes. As we have done for last year, we've updated residual mixes based on the most recent data available. This means the data reflects the situation in 2023 in version 3.11. And this update concerns all countries in Europe that are covered by the data published by the Association of Issuing Bodies. Moving on to the next sector, we have quite a few updates for the chemicals, which I'll be covering in the next slides. We have introduced new data and updated data based on data provided by the industry. And we have also made other improvements based on information taken from the literature. So first, what we have on this slide concerns the update of vinyl chloride and polyvinyl chloride datasets. The update is based on 2022 data provided by the European Council of Vinyl Manufacturers in collaboration with the IFOI Institute. The updated data for vinyl chloride reflects the average mix of technologies used in Europe, which includes two technologies, oxychlorination and direct chlorination. For PVC, we've incorporated updated datasets for both suspension polymerization as well as emulsion polymerization. These updates are quite representative for Europe. So for vinyl chloride, the data represents 68% of the European production volume. When it comes to SPVC, the coverage is 73%, while for EPVC, the data represents 81% of European production volume. This data has been recontextualized for the rest of the world geography, as the technologies used in Europe are assumed to be a better representation of the current situation for the rest of the world compared to the previous data that we had in previous versions of the database. With this update, we have also updates for the markets for both Europe and rest of the world for all three products. Finally, it's worth mentioning these updates are especially valuable for industries such as the building sector, sports gear, and furniture. A second notable update in the chemical sector concerns new and updated European data for unsaturated polyester and vinyl ester resins. These data were supplied by the European UPVE Resin Association with support from EY. The data is derived from a survey of industrial operations involving 5 European producers. The data for unsaturated polyester resins cover the production based on dicyclopentadiene isophthalic acid, maleic and ophthalic acids, as well as recycled PET. For vinyl ester resins, the dataset which was updated for version 3.11 models the production based on bisphenol A. These updates replaced the old European data that was available in previous versions. As the rest of the world datasets were based on the old European data, they have also been updated by recontextualizing the data introduced with this update. This update is relevant for the industries that consume these types of resins, such as the construction sector, the automotive industry, and the energy sector, among others. The third major update for the chemical sector concerns the introduction of datasets that model manufacturing services for composite materials. So this is brand new data that we did not have before. It was primary data collected from different factories in France by the IPC in collaboration with ADEME. The datasets that were introduced are modeled as services, meaning that the main input components that comprise the final composite materials are not included in the dataset. So this enables users to apply the services to different input materials. So hopefully this provides a bit more flexibility. The update covers several types of manufacturing processes used for composite materials, including compression, molding, pultrusion, manual processes, and filament winding. The French data was recontextualized to rest of Europe, North America, Asia, and rest of the world to enable a more representative data for users operating outside of France. This data is useful for users who want to model the production of composite materials, which is particularly relevant for the automotive and aviation industries, for example. Other highlights for the chemical sector in version 3.11 concerns the new and updated data for key chemical building blocks. So for example, in version 3.11, we have updated the modeling of synthesis gas and carbon monoxide. Back in version 3.10, the production of synthesis gas from natural gas was not covered, and the carbon monoxide data relied on partial oxidation of oil. In addition, the co-produced hydrogen was assumed combusted on site to cover the heating needs. For version 3.11, we have revised these aspects. And what is shown on this slide is the new modeling approach, which is depicted in the bottom diagram. Since the substances are used in large volumes as precursors for other chemicals, these updates improve the overall data quality of the supply chains of the chemicals that rely on the products covered by this update. A second example concerns the polycarbonate production process system, which is improved by the new data for its precursors, which include carbon monoxide, phosgene, cumene, and bisphenol A. These are depicted on the diagram in the middle. This update builds on the work completed in versions 3.9 and 3.10. So what we can say is that with this update for version 3.11, we have finalized the updates of the process chain for the manufacturing of polycarbonate. As last example, we have updated key chemical building blocks in the process system for diisocyanates, which are the main precursors of polyurethanes. We have updated data sets for several of the precursors, such as, for example, carbon monoxide, phosgene, and nitrobenzene. These updates provide improved data related to chemicals, materials used for the automotive industry, construction materials, paints and coatings, as well as materials used for furniture manufacturing. If you'd like to see these diagrams in more detail, please check the change report, which contains more details regarding these different updates. Last updates I would like to mention for the chemicals concern data expansion efforts, which cover new chemicals as well as covering new locations for some existing chemicals. We plan to continue such efforts for future database releases. So, for example, The number of chemical or plastic products covered in North America and Asia each increased by approximately 20 substances compared to version 3.10. The aim of this geographical expansion is to provide representation of consumption and production that reflects local conditions for those regions. We have also updated, or rather added, 18 products that were not previously covered in ecoinvent, which comprise of synthetic rubber, along with 11 organic and six inorganic chemicals. You can find the detailed list in the report of changes. Finally, we have also carried out what we call routine maintenance of data for chemicals and plastics. One aspect we have worked on is to replace 6 changes that were previously modeled with proxies, which is sometimes required, especially in the null data sets where the database was not as complete as it is today. And so by going back to some older unit process data and doing these replacements, we have improved the accuracy of the modeling for those unit processes. We have also replaced previously aggregated data, which were used for methyl chloride, methyl methacrylate, and polymethyl methacrylate. This data has been replaced with disaggregated unit process data so that the inputs are now linked to other ecoinvent processes, which was not the case before. So in this case, we have increased the transparency, but also the traceability of impacts for the supply chains of these compounds. So that's it for the chemical sector. The other sector we have updated is the battery sector. For this sector, we have enhanced our battery-related datasets with new data from literature sources, particularly focusing on lithium-ion battery technologies. So this update includes comprehensive datasets for both NMC 622 and NMC 532 battery packs, along with detailed subcomponent data for these configurations. In the anode materials category, we've expanded our coverage of graphite production in China, incorporating new datasets for natural graphite and updating the synthetic graphite manufacturing processes with data provided by Tokai Cobex. This update provides a more accurate representation of the battery supply chain in one of the world's largest production regions. We've also introduced new datasets for critical battery materials, including lithium titanate oxide production across multiple regions, specifically in regions where rare earth element processing is occurring, like the US and East Asia. Additionally, we've incorporated new data for electrolyte production specific to sodium-ion batteries in China. And in this way, this new data is reflecting the growing importance of this emerging battery technology. So these different updates for this sector have substantially improved our technological resolution for lithium-ion batteries, addressing critical data gaps in the battery supply chain that existed in previous versions of the database. The updated datasets provide users with greater flexibility in modeling various battery configurations, whether they're working with more traditional or alternative battery designs. The goal of these improvements is to better support the growing need for detailed environmental impact analyses in the energy storage sector. The next sector I want to cover is the sector for wastes. So for version 3.11, we have obtained new data on plastics recycling for different technologies. First, there is mechanical recycling in Europe. In the previous versions of the database, recycling of PET and HDPE were available. These datasets were updated for version 3.11. But more importantly, we have introduced datasets modeling the recycling of additional polymers, such as PE, LDPE, and PP, and the many others listed here. These polymers are contained in waste generated from all kinds of sources, and the data for these recycling activities was provided by Plastics Recyclers Europe, and it offers an extensive coverage of mechanical recycling of waste plastic in Europe. Another update related to waste plastic recycling concerns the introduction of a dataset modeling the hydrothermal treatment of mixed waste plastic in the United Kingdom. The process can be characterized as a type of chemical recycling that treats mixed waste plastic that cannot be mechanically recycled due to heavy colorants, additives, mixes, and other types of compounds. The final products generated from the process are naphtha, distillate gas oil, heavy wax residue, and heavy gas oil. This data was provided by Mura Technology, and it represents the only plant in Europe that performs chemical recycling on an industrial scale. A similar technology of chemical recycling was also added in the geography of China. The process deals with waste polyester sourced from industrial activities of textile production, and it is chemically treated into polyethylene terephthalate pellets. The technology of chemical recycling is still not well established across the world, as it is mainly performed in pilot scale projects. But we do expect further expansion in the coming years. However, these additions for version 3.11 allow users to already assess the end of life of waste plastic by comparing the different alternative recycling technologies that we currently have. Another update for the waste sector concerns the regionalization of the treatment of municipal solid waste in countries located in Europe. The treatment technologies employed range from open dumping to incineration with energy recovery. These treatment processes were modeled with our internal waste tool, which was developed by DOCA. As input to this tool, country-specific data on waste composition is needed, and we collected this data from various literature sources depending on the geography. The treatment mixes, meaning the mixes of treatment technologies that are modeled in the market datasets for municipal solid waste for each country, were built based on Eurostat data as well as DOCA's model. The last update I want to mention for the waste sector concerns a nomenclature change. So we have metal waste that are not recycled, which had in some cases the term scrap in the name in previous versions of the database. To make the fate of such waste more explicit, we renamed these exchanges to replace scrap with the term waste. So one example is scrap copper, which we have now renamed to waste copper for version 3.11. And we have also renamed the corresponding treatment activities. While performing this update, we also revised which type of flow was used by the activities that generate these waste or recycled materials as byproducts. So this means we assessed each activity to identify whether the material goes to final treatment or to recycling, and then we made some changes in certain cases. Now moving on to the agricultural data. For this sector, we have one major update introducing new data for Swiss agricultural production. This was done in collaboration with Agroscope, our Swiss data provider, who have done the data collection work. This release includes over 130 datasets covering fruit-bearing trees like apple and pear, cereal grains such as barley, maize, and wheat, root and cruciferous vegetables, including carrots and cauliflower, as well as protein-rich legume crops like peas and fava beans. Both conventional and organic farming methods are covered, and the data is also split between specific regions in Switzerland, covering, for example, mountainous regions, hill, as well as plain subregions. This project increases the number of products that we have in Switzerland, as well as providing us with more regionalized data for agriculture in Switzerland. For the construction sector, we have expanded this sector with new datasets for limestone, clinker, and cement production in Canada, as well as the province of Ontario. This new data was provided by the National Research Council, NRC, of Canada, and this project resulted in the creation of 8 new datasets, introducing 2 new cement types into the ecoinvent database, which are the general use cement and general use limestone cement. Our collaboration with the NRC will continue in the next versions of the database with, for example, data on concrete mixes. As part of this update, we introduced a new infrastructure called Integrated Cement Plant, which is used for the clinker and cement manufacturing in Canada. And this new infrastructure is modeled based on aggregated data that models essential infrastructure and equipment used in those facilities. In addition to this Canadian data, we have also made updates to over 90 datasets in the construction sector, covering products across 12 geographies. We have updated production volumes for materials such as concrete blocks, quicklime, and hydrated lime. And we have also made revisions in the datasets for limestone quarry operation and sand quarry operation. We revised exchanges across several other processes, particularly for glazing and concrete products. You can find more details about these different updates in the report of changes. For the pulp and paper sector, there are 2 significant updates that I would like to mention. The first one concerns updated data for kraft paper and paper sack manufacturing in Europe. This data represents average European production in 2021 and was provided by the organizations CEPI Eurocraft and Eurosac. Compared to previous data sets from 2018, the updated data on kraft paper production highlights some important trends that have been observed in the industry. And this covers, or this concerns, first, a reduction in energy consumption, which means there's been an improvement in the efficiency of the manufacturing processes. And also we have an observed decrease in the relative share of fossil fuels in the total energy usage, while the share of biofuels has increased. This update provides more accurate and up-to-date information for industries that use kraft paper and paper sacks, such as the retail and construction industries. The second main update concerns the introduction of 3 new datasets for single-use paper-based tableware. These datasets represent European production as of 2022 and were developed with data provided by the European Paper Packaging Alliance. Paper-based tableware is commonly used in fast food restaurants in Europe, in large part in response to EU regulations that restrict the use of single-use plastics. The data covers a wide range of products commonly used in fast food restaurants. So we have, for example, data representing the production of beverage cups and lids, as well as ice cream cups and salad boxes. We have another data set representing the manufacturing of grease-resistant burger wraps and fry bags. And thirdly, we have data modeling the production of clamshells for serving of burgers. These data sets aim to support food chains, event organizers, and regulators who want to assess the environmental impacts of paper-based food packaging. We also have some updates for the metal sector. We have added data for a new type of steel that was not covered previously, which is grain-oriented electrical steel. It is a special type of steel that is used in electromagnetic devices such as transformers. It requires steel with 3.2 silicon content as feedstock, and a separate data set has been introduced to model the production of this silicon steel. Another metal that has been updated for version 3.11 is gallium, which is used mainly in the production of integrated circuits. Gallium production already existed in previous versions of the database, but it was modeled in a single step. What we have done with this update is split it into 2 steps. This was performed by EMPA, institute located in Switzerland. The first step models the production of low-grade gallium from gallium contained in spent bioliquor, which is produced during the production of aluminium hydroxide. The second step models the refining of low-grade gallium to high-grade gallium. With this remodeling, gallium now gets burdens related to the aluminium chain, which was not the case in previous versions of the database. It also has been now modeled for China, which is the country where most of the production is taking place. The last update I want to mention for the metal sector concerns prices, which have been updated for around 60 metal products. The price data comes from the ISC database. The change in prices has caused shifts in the allocation of burdens in datasets that produce at least one of these metal products and in which economic allocation is applied. So this shift in burdens is happening in all attributional system models, since these system models apply economic allocation. So this is something to keep in mind as it affects the scores for supply chains where metal products are used. The last sector I will be talking about is the transport sector. And here there are 3 updates I would like to highlight. We have updated the European and global passenger car fleets. This update is based on various statistics from Eurostat, the International Organization of Motor Vehicle Manufacturers based in France, and other sources of statistics for passenger cars. With this update, we have a better representation of the current composition of the passenger car fleet, both in Europe and the rest of the world. Another update concerns the activity names of datasets that model transport. What we did for the version 3.11 is we harmonized the way activities and exchanges are named throughout the whole sector. In this way, we have reduced inconsistencies that existed between different means of transport, and we have now ensured that the same structure is followed for all names. And so this concerns both activities and exchanges. And hopefully this should make it easier for users to search for transport datasets. Lastly, we have introduced new datasets that model the maintenance of aircraft. This update enables a more accurate modeling of the use phase of aircraft. And this data was compiled by the German Aerospace Center. Now moving on to other updates. So in addition to the updates made for the different sectors, which I've covered so far, we have also made some changes to the impact assessment methods, which I'll be describing in the next slides before I move on to some features available to the users of the database. So for the lifecycle impact assessment methods, the main changes are summarized here. We have a major update that concerns the characterization of biogenic carbon dioxide. To enable this update, we first updated biogenic or non-fossil carbon flows in the unit processes throughout the database, where these flows are relevant. And we balanced them while paying special attention to biogenic carbon uptake. So these changes enabled us to then characterize non-fossil carbon dioxide with -1 or +1 for removal and releases, respectively. This is done in the context of assessing climate change impacts following the IPCC methodology. And this is demanded by some standards and guidelines such as ISO 14067. The other change I will give more details about is the change concerning the naming used for the EN 1584 impact assessment methods. We have done some restructuring, which I'll explain in a bit more detail. So regarding biogenic carbon, previously biogenic carbon was not characterized in ecoinvent. So to introduce this, we have now biogenic carbon considered with a -1 and +1 characterization in a new method that is complementary to IPCC 2021. We have called it IPCC 2021, including biogenic CO2. The impact categories of the two methods can be mapped to standards and guidelines. We have, for example, in the table on the right here, the ISO 14067 standard shown, and with an indication of which impact categories are relevant for that standard. What we call in version 311 IPCC 2021 corresponds to the same methods as in version 310, but with a few adjustments. The impact categories were renamed to be explicit about biogenic carbon. So for example, the category that was called previously just climate change is now called climate change total, excluding biogenic CO2. Also, aircraft emissions are provided separately in a new impact category. And to be complete, the fossil emissions, excluding aircraft emissions, are provided as well. To increase transparency, emissions and removals are available separately for the land use impact category, which is renamed to direct land use change, as this is what is available in the ecoinvent database today. Some standards and guidelines also require reporting the carbon or carbon dioxide captured in products. And this information is provided in a separate Excel file containing carbon contents of products in all unit processes in the database. And this is a file that you can access in our database. We do recommend using IPCC 2021, where biogenic carbon dioxide is characterized with 00 whenever possible. And the reason for this is that scores including biogenic carbon dioxide are subject to potential distortions related to allocation. And there's also the risk of overestimating uptake. So these the categories related to the new methods should be handled with care, especially if the scores are negative, and they should never be used as a stand-alone method. The second main change I want to mention concerning the impact assessment methods is related to the methods used in EN 1584. So this is available as a separate system model. The impact assessment for the standard EN 1584 is based on the EF method and was so far named accordingly in the ecoinvent database in previous versions. However, in these standards, impact categories are grouped in a specific way in different tables. So what we have done for version 311 is we have rearranged the EN 1584 impact assessment indicators into different methods following the grouping and terminology used in the standard. So what you will find now is, for example, core and additional impact categories, as well as indicators that follow different groupings. You can find the detailed list of indicators in the supporting files of the database. So the last part concerns additional information and features. So first of all, where can you find more detailed information about version 311? Here you can see the support page with the link provided. On that page, you can find the report of changes, which is the document which reports in much more detail the changes we have done for this new version. So if there's anything that you want to read more about, or if you want to get the full picture of all the updates done for a given sector, please go and read that document. Alongside it, you can find other useful documents, such as the correspondence file, which is useful for users who are switching from version 310 to version 311. And we also have, for example, the database overview file, which gives a complete list of all datasets contained in the database. And so for users who don't have a license or don't have access to the database, you can use this file to see what exists in this newest version of the database. For looking at the data, we have the EcoQuery platform, which we can access through our website. It was updated last year and gets continuous updates. So what you can see here is the homepage. You can use it to browse the database. Anyone with an ecoinvent license can access the full information, but even without a license, you can already see some information about the datasets contained in the database. So for example, what you can see is the documentation of unit processes. So even without a license, you can access this information. However, the information about exchanges, for example, or the impact scores, these are reserved to licensed users. We also make quite a few files available in EcoQuery for licensed users, and this is available in the Files tab. And what you can find here is, for example, the whole database in XML format. But you can also find some useful Excel files, for example, a file containing all impact scores, as well as a file containing the GHG emissions for different scopes. Lastly, if you have any questions about the database or you want to know more about how the database is modeled, you can check out the knowledge base. And our knowledge base basically contains different types of information about how the database is structured, but also information about the different sectors covered, among other things. And through that page, you can also access the support ticketing system. So in case you have any questions for which you couldn't find answers in the knowledge base, you can easily reach out to us. And this wraps up this presentation. You have here the link that would allow you to contact us in case of any questions or feedback. And of course, these updates that we do every year are only possible thanks to data providers. So if anyone has data they want to provide to ecoinvent to make it available to the rest of the ecoinvent community, then feel free to reach out to us. We would be happy to provide you with help to integrate your data and make it available to the wider community. You can also use the QR code here to connect with us on LinkedIn in case you would like to stay up to date on the latest developments. Thank you everyone again for joining us today. It's been a pleasure to present to you version 3.11 of the database, and feel free to get in touch later in case you have any questions or in case you would be interested in providing data. Thank you very much.